Hello everybody, this is Jakov Fein with Farata Systems. Today is the third lesson of our training, Java programming, Intro to Java programming. In this unit, we'll talk about bits and pieces from the language. Usually, books or training classes starts with small elements, with syntax element or constructions of the programming language being taught, but I prefer start with main concept with object-oriented programming in Java. So this is what we did last time. We will go back to that, but for now, just selected bits that you need to know to be efficient in Java. Or actually, these are basic things that every language has. Arrays, loops. We'll cover packages, access levels, and the command line argument in this subject. Arrays are used to store a bunch of similar objects or similar primitives, similar values. In this example, I show you I want to store the names of my friends or girlfriends, for example. So I can create an array. I named it friends, but these square brackets is the reason why the variable friends is not a regular variable but an array. The square brackets you can put either after the data types, like in here, after string, or after the variable name itself, over here, right after the friends. In both cases, Java will understand that you're declaring an array. When you declare an array, you have to know how many elements you are planning to put in that array in advance, and you need to specify it in advance when you create an array, as in here. In here I said I want to create a new array that will store 20 strings. If I said so, then I can initialize the array, as in here, friends 0 equal Masha, friends 1 equal Matilda, friends 2 equal Rosa, and so on. But I cannot change, during the runtime, I cannot change the size of the array. I would need to do something special. I would need to create a copy, make a copy, arrange for a copy of the array. But I cannot just simply say during the runtime, no, I don't want 20, I want 30. So that doesn't work this way. What else I want you to note? The first element of the array has an index of 0. Basically, arrays are 0 based, as we say. So accordingly, the last element of the array will be element number 19. 20 elements total. As you can see from here, I did not assign any values to elements between the elements with an index 2 and elements with an index 19. What's going to happen in there? Those elements will be not initialized. They will have the value of null. Null basically means nothing, no value at all. Another way of initializing array is by declaring and initializing it at the same time. In the middle section of this slide, you can see that I declare this array, and immediately I assign the value in curly braces. You can assign the values to this array. So I assigned 4 values in this case, which implicitly define the size. The rules are still the same. You can change it afterward, but you didn't specify it explicitly. But just by the fact that we assigned 4 values, Java knows that this array is the size 4. You can say that it's not that great. How come I cannot change when I need to? But as you know, there is no free lunch, and you have to pay for everything. So if you have an array which has this restriction, then memory allocation happens only once, which means arrays works faster than other data collection. Java has other data collections which are more flexible. They do allow you to change the size. For example, array list. But what happens, they do this work underneath anyway. They reallocate the memory every time the program changes the size of the array. So this is what I mean when I say that you have to pay the price. With arrays, you have this restriction, but memory allocation happens only once. How do you create instances of string? It's not exactly related, this topic is not exactly related to arrays, but since we're already working with strings, I need to spend some time talking about strings. Strings in Java is a special data type. Strings are object, of course, but they are immutable. They are not being, even if you think you're changing a string by concatenating a string from two or more pieces, or you're replacing the value of a string, technically the original string remains the same. It never changes. Java maintains so-called pool of strings, and this pool of strings would keep every value of a string. Even, say for example, if you created a value of a string like in here, name Oksana, and then you decided to attach the last name to the same variable, mygf mygf plus Smith, Oksana Smith. Then you're going to have a situation when you have two strings in memory, in Java's memory, in string pool, as we say. You will have one string with the name Oksana, the other string with the name Oksana, with a value, Oksana Smith. You can create strings in different ways. One of the ways is by just using a string literal as the last line of this slide. String mygf is equal Oksana. Or you can use the operator new as you use with any other object. New string, and then you specify the value to the constructor of the string class. Later on in the homework, I'm going to give you a quiz, and you will need to think about what difference would it make if you initialize the string with the literal or using the new notation. Arrays in Java could be one-dimensional, as in previous example, or multi-dimensional. As in this example, I want to create an array that has 2 dimensions. So to specify that, I specify 2 empty square brackets. For example, I want to store, for each person, I want to store the name and the phone number. So I still have 20 elements for the friends, but each of them now will have, in the second dimension, it'll have the name and the phone number. As you can see in here, you initialize them by specifying indexes for each dimension. Friends 0, 0 is equal, like in this case, Masha. Friends 0, 1 is equal this phone number. Again, the next element, first dimension, changed, right? Friends 1, 0 is equal Matilda. Friends 1, 1 is equal phone number, and so on. There is no restriction on how many dimensions you can create an array. Of course, use your common sense, and to be honest with you, in Java there are better way of dealing with situation like this, with storing multiple properties of the same object or the same class. Like in this case, friend. I would create an object with several properties, like with 2 in this case, name and phone number, and I would be storing these objects, instances of those objects in the array. But as an illustration for multidimensional arrays, it works. This slide works. Wrapper classes and autoboxing. Java has primitive data types, 8 primitive data types. And for example, like int, float, double, boolean, right? Each of these primitive data types has the corresponding so-called wrapper class. For example, primitive type int has a wrapper class integer with capital I. That's the name of the class in Java. Why they are needed, why they are helpful? First of all, they have these classes, wrapper classes, have lots of useful utility methods that deal with the corresponding primitive type. For example, you have an int primitive value of int, and you want to convert it to some other type. Most likely you can find the appropriate useful method in the corresponding wrapper class. So let's see if we can do that. 1 second. Let's see if we can do that. I will do search on Java API integer. I want to find help on Java. See, we found help on the wrapper class integer, and in there I can read everything about what's available for dealing with integer values. All utility methods are there. But before even looking at these methods, let me point you at something else. Look at this inheritance hierarchy. Everything in Java has a superclass. The top of the hierarchy is a class object. In this particular case, the class integer, I can see that the class integer extends from the class number, which in turn extends from the class object. What is this java.lang? We'll learn a bit later in this lesson. This is the name of the package. Every class in Java is located in some package, being that a default package or a specific package. In this case, I can see that the class integer was defined in the package java.lang. Package names are used to better qualify the name and to avoid naming conflicts, but again, a bit later. Next, you can also, from this help, you can also see that the signature, in the signature of the method, you can see that it's a class that was defined as public, and it extends number. So far we didn't learn what is implements keyword means. It's about interfaces. We'll learn it next in the next unit, but for now let's just skip it. Now if you want to see what are the methods, I click on top. See how many methods are there? So a bunch of values, a bunch of methods, and for example, let's find something interesting. See, for example, short value. The method short value returns the value of integer as a short. In Java, there are different primitive types, and one of the primitive types is so-called short. It takes less memory than integer. So, if you believe that the value defined in this integer variables is small enough that can fit in the short variables, you can convert it to short. Or let's look at this one, parse int. So it can take a string, and if you know that this string contains digits only, then that can fit into integer. You can convert the value of this string into the primitive int. So again, my point is that wrapper classes have lots of useful utility methods, and if you are facing a situation when you need to do something with a particular data type, this is your first step. Find the appropriate wrapper class and see if you have a solution there. What else? The other situation when the wrapper classes are useful is when you deal with collections. In some cases, a collection allows you to store only objects in there. So you cannot store primitives in the collection. For example, here's a collection called array list. Remember I told you arrays are not flexible. You have to specify the size in advance. On the other hand, array list is flexible. It allows you to add elements as you need them to this collection. But array list doesn't allow you to store primitives. So what you can do you can wrap them in using a special using the corresponding wrapper class. For example, you want to add a primitive value of 6 as an integer to the collection, to the array list my lottery numbers. There is a method add in the array list, and you can do that, but the method add requires you to specify an object. So on the fly, we create a new instance of the integer class, of the wrapper class, and we wrap this 6 inside. Similarly, we wrap the value of 15 and add another value to the my lottery number collection. And let's look at this line. My lottery number at 6. In this case, I don't wrap the value of 6 into the wrapper class, and you can say, how come? You just say that you have to. Yes, and Java helps you with that. There is a feature in Java called autoboxing. When Java will see something like this, it'll automatically create an instance of a wrapper class, and technically in this my lottery number, after this line, it'll be storing an integer instance of an integer wrapper class, which will hold the value of 6 inside. Accordingly, if you want to extract a value from the collection of objects, if you will specify something like this, my lottery number dot get 23, get element from the array list with an index of 23, whatever is sitting in that place. And on the left hand side, as you can see, I put primitive int lucky number. How come? Again, you were storing instances of the object in that collection. How come you are getting primitive? Again, the same story. There is autoboxing and there is unboxing. Unboxing works in this way, which means that Java automatically will take the instance of an object, extract the primitive from there, and return it to you as a primitive. In this particular case. Probably I want to stress that it's optional, it's up to you. If you don't want to extract it automatically to do unboxing, you could have created an instance of integer and get the value that way. But we decided that we need a primitive, so unboxing works automatically. Next example is loops. 4 loops in this case. In any programming language, you need to have a way to repeat certain actions multiple times, the same action multiple times on some collection of objects, or for any other reason. Maybe you have a counter that you want to use and repeat certain actions so many times. In Java, you can have 4 loops, and you can have while loops. Loops as a syntax element. There are other ways of iterating or traversing a bunch of elements, a set of elements. But if we talk about the loops as a construct of the language, Java has 4 loops and Java has while loops. 4 loops also, they have different syntax, different ways of specifying. For example, in this case, I have a loop which starts with I have a temporary variable I, which I will be using for iterating something. I start with I is equal 0, and I check the value of I on every iteration of the loop. If I is less than certain value, in this case I want to iterate through the arrays, through the array elements. So first I find how many elements are there. Arrays in Java have a property length, so I can ask how many elements do you have there. I store it in the variable total elements, and I starts with 0, and until this expression is true, until I is still less than total elements, I will be entering, not I, the program will be entering the loop body. The loop body is whatever I put between the curly braces. And on every iteration of the loop, we will enter the body, execute every line inside the body, and then the program will go back again to the for loop, to the first line. It'll make an increment. In this case, I++ means take the value of I and increment it by 1. and again it'll check the value, the expression. Is I still less than total elements? Yes. Then it'll get again inside the curly braces, inside the loop body, and it'll repeat this action. In this case, I just print the sentence I love, and I concatenate to this text the current value of the i's element of the array. Speaking of this operation, I++, I++ is something, as in older languages, was specified by saying I is equal I plus 1. I is equal I plus 1 means take the value in the variable I, increment it by 1, and put it back. Assign it back to I. The shorter syntax, and it's the same as in C++, as in C#, I++ does the same exact thing. For example, if I initial is equal to 0, you can do I++, and it'll become 1. If you'll do I minus minus, it will do a decrement. So again, I will again become 0. I also want to tell you something, and this something will be your little research after this lesson, whenever you want to do this. You can write in Java these ++ increment after the name of the variable or before. There is postfix increment and prefix increment. I want you to find the difference on your own. Do your little research and see why and when it can make a difference if you put the pluses after the variable name or before. Anyway, coming back to the loop, so the loop will iterate through and will perform the command from the body of the loop until the expression of the loop is true, returns true. Evaluation of this expression returns true. As soon as it becomes false, for example, I reaches the value in total elements, like 20, for example. Whenever the I become 20, in our case with array friends, then this condition won't be true anymore, so the flow control, the program execution, will not be entering the loop anymore. It'll continue execution of the program, and it'll continue to do whatever code you put below the loop. And two more keywords that you must know if you want to work with loops. There is a keyword break and continue. Break and continue. What are these about? If you want to jump out of the loop at any given time, even before you iterated through all the elements of the array, if this is what you want to do, you need to put the keyword break. The keyword break jumps out of the loop and continues the program executing whatever you put below after the loop. Why you may want to do that? Maybe say you are looking for a particular element inside the loop. So you can put an if statement inside the loop. Say, for example, if the name stored in the current element of the array is equal Mary, then jump out of the loop. Or maybe jump out of the loop and print yes, Mary is in the list of friends. So as soon as you found Mary, there is no reason maybe for you to continue iterating to the end of the array. So break would help you in that case. The other keyword to learn is the keyword continue. Continue. Another example. Say you want to print the message I love, and for every element in this array except Mary. You don't want to print the message if Mary is in the list of in that array. So what you can do in here, you can have still the same loop. You iterate through the loop, but inside the loop you can put an if statement, and you can put in there if this current element, if friends of I is equal Mary, then you do continue. If you'll say continue, then the body of the loop will not be executing whatever is after the word continue, but it'll go back to the for loop expression. It'll Technically, it'll skip processing for this element where you put continue, and we'll go back, we'll increment the value of I, and we'll keep processing. It will not jump out of the loop, but it'll skip the processing of the current element. That's what continue is for. Another very, very useful and practical syntax, in my opinion, it's in many cases preferable way of writing for loop. It's so-called for each loop. If you have a collection and you want to do something for each element of the collection, what you can do, you can use a different syntax that is called for each loop. Let's see how you write that. You put the keyword for, and then inside of the parentheses, you don't put I equals 0, expression, I++, or whatever. You just create a temporary variable of the same type as elements stored in the array, in this case, string. And basically, by how do you read this expression? You read for girl in friends, for a variable girl in, this column would be read as friends, as in. For girl in friends, do something. The rest Java will do for you. Java will iterate. Java will make sure that this variable girls first it points at the very first element of the array, then to the next one, to the next one, to the next one, and so on. Assume that this variable, temporary variable girl in this case, is always a pointer that points at the current element of the array in this case. And whenever it reaches the end of the collection, end of the array, then the loop is over and it'll continue with an execution of the further statement that you put in your program for each loop. At the bottom of the slide, I put a note that Java 8 offers. Java 8 is coming up in March of 2014, in a month. And Java 8 has a very useful method that you can apply to collections in there. If you have a collection, you can just say collection dot for each, and whatever you put in there as a function to execute will be executed for every element of the collection. At this point, we are not going to be talking about details of this for each method, because it would involve explanation of other things, in particular lambdas. It's a new feature in Java 8. I'm planning in the future to record a special unit or special lesson that will highlight the new features of excellent new version of Java 8, which has really many, like more than 50 like major useful improvements in the language, in the syntax of the language. But if you want to read about it now, I put a link at the bottom of the slide. Go ahead and read about it on your own. While loops. While loops is a different syntax for writing, for repeating some action multiple times. Let's see. You write a keyword while. In parentheses, you write an expression, which means repeat the execution of the body of the loop, whatever we put between the curly braces, until this expression is true. So in the curly braces, you will write some code to do something, and then obviously you need to make sure that that expression is changing. Otherwise, you will get an infinite loop. If for example, you will forget to put I++, total elements is 0, I is equal 0 in the beginning, 0 is less than total elements. If I will forget to modify, to increment the value of I, this loop will never end, and we call this situation an infinite loop. The other syntax of the while loop is so-called do while. You start the loop body with the keyword do, and then a pair of curly braces. Whatever is in between curly braces is the loop body, and at the end, after the curly braces, you put the expression on which to end the loop. So you can read this on green. You can read this loop, do something while I is less than a total elements. What's the difference between the left loop, which is in the blue background, and the right loop? The difference is that if you write do while loop, the content, the body loop will be, the content of the loop body will be executed at least once. No matter what, you always will be entering inside the loop. Then after the first execution, you will be checking the condition. Maybe it's time to exit the loop, maybe not. On the left hand side though, there could be a case that you will not even enter the loop body if this expression is never true. Again, so do while loops are guaranteed to be executed at least once. And now let's do a quick walkthrough. I will do most of it in front of you. Here's the while loop. It's a class. While loop demo, I called it, right? So I initialize the array, declared initialize the array, and then I write a loop for every element in the array. I want to print I love the current name, right? But I don't want to print empty elements. See, I initialize element 0, 1, 2, and then nothing until 18 and 19. So in between there will be an empty element. I don't want to print anything. I don't want to print I love null. So what I do inside the loop, I will compare. If the current element of the array friends is equal to null, please note I put double equal sign. Don't confuse it with equal. Double equal means I am comparing. I am not assigning null, which would be the case if I would have written single equal sign. I am comparing the element I with null. If it's null, I just increment the variable I and I write continue. Continue means go back. Don't execute whatever is underneath. Go back and enter the loop again with a new value of I, of course. If friends I is not equal to null, then we will reach this point. We will print I love friends I. We will increment I anyway. And again, the control will go back to the while loop. This is how it goes. And at the very end of the program, I print the iteration is over. Let's go to Eclipse. I already prepared this example for you. I typed it in Eclipse. Here's the code, exactly the same as on the slide. And let me run it. Right click, run as Java application. See at the bottom, I love Masha, Matilda, Rosa, Hillary, and so on. It print only those elements which were not null. Which were not null. Let me show it to you in the debugger. I will put the breakpoint on the line 15, and then I will run it through a debugger. Debug as Java application. Java application. So we are standing on line number 15 over here, the debugger. Step over. See, it didn't enter the if condition. Why? Because the current element I is 0 and friends of I was not null. See, there's a bunch of nulls in there. By the way, if you want, you can add a watch expression, so called. For example, where is that? I want to window show view expressions. It's a debugger thing. I want to have this view open expression, and I want to add a new expression. For example, I want to see the value friends of 0. See, it shows me what's in there. Of course, you can see it this way. But if you want to watch certain values in the debugger, you can create expression for them. Not only the values, but you can even put expression over here if you're interested in the certain ones. So now I hit resume, and this resume will continue until it'll hit the breakpoint again on line 15. again, and again, and again, right? So let's see what's in there. Sorry, let's look at the friends elements. Let's look at the friends elements. 0, 1, 2, Rosa. After Rosa, we don't have values for some time. So I is equal, what is the current value of I? I is equal 4. Let's do step over. Check this out. We ran into first null. So we entered the loop. We increment the value of I by 1. We are on continue, line 18. Now it's going to go back to line 13. Return back. See that? That's how continue works. Again, we have another null, continue, and so on. Let me remove the breakpoint from here, and I will resume the execution now. I didn't remove the breakpoint. Right click, toggle breakpoint, removed it, and continue all the way. See, it finished the same way as it did before. I just illustrated these nulls and how you can run it in debugger and expressions view, as you remember. Let's go back to the Java perspective. Basically, we covered everything here, right? Let me do this. I will comment out this block that checks for null. See this? Now it's commented out, and I saved it. If I will run this program now, it'll print me the whole bunch of I love null as well. It will be printing everything regardless of the value, right? Look at this. Okay, so you got my message. You got my message. You do the same thing at home, of course, and this step number 3 I didn't do. Just it's very simple. Check it out on your own. You want to use a break keyword for this to see how you can break out of the loop. Debug, we went through debugger, right? And one more thing that we want to cover today, one of the subjects is command line arguments. If you remember during the very first lesson when we started a program from the command line, I entered Java space and name of the compiled class. To compile it was Java C, name of the source code, and to run Java space name of the compiled class. Back there, we did not specify anything in the command line. But in this case, if you see here, I entered something else after the name of the program. These are the values that I can pass from the command line. Remember our tax calculation program? I'm using there gross income, dependence, and state. Gross income, dependence, and state. So these are exactly the values that I'm passing to the program test tax. On the last lesson, we had hard-coded values for gross income, dependence, and tax. And as you understand, nobody will ever buy a program that can only work if the gross income is equal $80,000 and you live in New Jersey and have 2 dependents, right? In this example, we are passing these 3 values, and if you remember, when we created this program first, there was a main method with arguments, string array of args. We never used it so far, but we will now. We will do it now. If during the launch of the program you specified something on the command line, Java runtime will obediently pass it, and it will through this array args. It'll create array args, and it will initialize it with the values from the command line, as in here. After starting this program, args 0 will have the value of 50,000, args 1 will be equal to nj, and args 2 will be equal to 2. Please note that all these values will be given to your program as strings. See these double quotes? Even though you need 50,000 for calculations, for example. But it's your responsibility as a programmer to convert in your main method the data to the appropriate time. If it's 50,000, if it has to be treated not as digits but as a number, then be my guest and convert it to say double or whatever value you want. How to do this? Right at the end of the slide you can see how to do this. Again, here's the use of the wrapper class double and its utility method parse double. So you take args0 and you apply parse double, it'll return you the primitive double value. It converts the content into the primitive double. So you can say that's great, but I like Eclipse. Now you explain us how to use Eclipse. I don't want to use command line. Is there any way that I can do this while sitting in Eclipse? Pass command line arguments. And the answer is yes. The answer is yes. So let me go back to the example from the previous lesson, test text. See, we have this hard-coded section, lines 11, 12, and 13. Nobody needs this program. We want the program to be flexible so it can consume data from outside and process the data, right? Not like in here. So what you can do, you need to configure the run. And the Eclipse has special configuration screen. Right-click on this program, select Run As, but don't run the program. Select Run Configuration over here. You do Run Configuration and select which program is your runnable main program. Now we want test text. We want to configure the launch, the run of the class test text in the package OOP, right? And over here I have different tabs. One of them is arguments. I did it in the past, but let me do something different. So there are two boxes. One of them for program argument, the other one is for VM argument. VM arguments is a place when you can configure your Java virtual machine. For example, maybe you want to allocate more of a heap memory in there. So you would be specifying specific parameters like XMS, MX. For example, there is minus XMS. This is this parameter which shows the minimum size of the heap memory. There is parameter XMX. So you can specify values in there, but it's besides the point. We will not be going there. What we want to specify program arguments, right? Gross income, number of dependents, states. For example, I can specify 65,000 as a gross income. I can specify Massachusetts as a state, and I can specify 3 dependents. So these values will be passed through the command line arguments mechanism, as I explained you before. Run. It still runs and still calculates something, but let me put a stop over here on the line 11 and run it through a debugger. I want to prove you that we got an array values in the array args. So debug as Java application. We are staying on line 11, but I want you to see the args element. See, args is an array. Now it has 3 elements. Let's open it up. Element 0 has 65,000, element 1 has MA, and element 2 has 3. All of them are strings. See, they are all in double quotes. So of course, if we will be using this mechanism, we don't need the line. We don't need hard-coded values over here. Let me stop this. What I would be doing instead, I'd be let's do double G income, for example. Actually, no. Actually, yeah, let me do a separate line so it'll easier to explain. Double GI is equal double dot parse double. And see, it tells me, give me a string and I will convert it into something. So I will be giving you a string args0. This is where I entered my $65,000. Remember that? Look at this. Let me put a stop over here. actually save. I'll go back to the Java perspective. In here, the value of the variable is not used. That's okay. Right click, toggle breakpoint. Did I put it there? I did. Let me see. Yes, it has line breakpoint. All right, so let me run it. Right click through debugger. Debug as Java application. See, now it's standing on the line double GI. GI so far is not there. Let me add it to the expression. Actually, we will see it over here in a minute. args0 is 65 as a string. Let me do step over here. The variable GI is 65. Now it says decimal. So now I could have assigned it to the gross income inside the object 80, inside the object T. I didn't do it, but I could. My point is that you can work with these strings and you need to convert them into the proper values, proper data types. Next, packages. Next topic. Realistically, your projects will have hundreds of files, at least several dozens if it's a small project. A team is working, everybody creates classes, interfaces, so the project grows. And if you have 200-300 of classes, do you want to store all of them in the same directory? Probably not. First of all, you want to organize them better by splitting into different subdirectories. Maybe you want to have a subdirectory where you keep all the files that are responsible for the user interface, UI files. You may have another directory which will have all classes that are responsible for calculations of taxes. You want to create another directory which will be dealing with a database, classes with a database. So you can organize files better. Besides that, we live in the world when people are reusing somebody else's code. So say you are creating a library to calculate taxes and you sell it to different accounting houses which are incorporating it in their software. So they have a software they bought from you, the library to calculate taxes for the state, for example, or maybe for the country. And now you need to integrate their code into your code. Is there a chance that there will be some clash between their class names and your class names? Maybe you have a class named tax, and they have a class named tax. Which one to use? How to distinguish them? To do that, you will be using packages, of course. You want to make sure that fully qualified name of your class text is different from fully qualified name of their class text, of that firm that gave you the software. So we want to make sure that our classes are unique. How to ensure something like this? Is there a way to find something unique in this world? Yes, there is. The smart decision was made at some point to use a so-called reverse DNS notation. What is DNS? A domain naming service. Each of you is using it every day whenever you are online. When you specify www.cnn.com, you go to cnn.com. And there's only one main web server that receives that request from around the world. First of all, the company CNN purchased the notation, purchased the name cnn.com, domain name, right? And then all internet service providers around the world, they have their databases synchronized with the valid names, domain names, mapped to valid IP addresses, valid servers, unique servers. So CNN.com, you can say it's a unique name, right? So, or you work for a company called Acme. There is a website called acme.com. If you will reverse this name, you will get com.acme. So if we will be using prefixes com.acme in front of every our class that we create in the application, then we are guaranteed that only this company will have names with such prefix. Of course, CNN.com would be developers in there would be starting their class names with com.cnn.something else. So reverse DNS gives us unique prefixes. And for example, if you are working in a company Acme and they have a website called acme.com, then you can create a package named com.acme dot and then something more specific. Maybe we work in the accounting department over there. So you can create a package com.acme.accounting. If you wanted to split further down, you would be creating com.acme.accounting.ui directory for storing UI classes for the accounting application, or com.acme.accounting.calc engine or text engine, another directory, and so on. If you create a package, if you define a package is it's a command, it's a keyword package in Java. You must have this keyword on the very top of your Java code. You cannot put anything above the line package besides the comments, except the comments actually. So if you specify that package is so and so, then accordingly on your disk you have to have a corresponding directory structure. You have to have a directory com with subdirectory acme and with subdirectory accounting. So the class text in this example will be sitting inside the subdirectory accounting. Now we have a situation, say your main class, the starting program, which is test text, is sitting at the root of your application in the src directory, if we talk about Eclipse, but your text class is sitting deep down inside the subdirectory com acme accounting. So how the text tax program knows where to find that guy, the tax class? You can do it in a couple of ways. The most popular way, you specify the import statement. Above your class test tax, you specify an import statement for all classes that your program may be using. As in this example, import com.acme.accounting.text. When you do that, and if you will start using inside the program test text something like this, your program test text will know where to find the definition of the class text. Why? Because this import statement, it means if you cannot find it in the current directory, go and check it out over there inside the com acme accounting. The other choice would be to specify fully qualified name all the time. So again, say we are sitting inside the test text program and we want to use text class, which is sitting in a different directory. So I could have specified like this: com.acme.accounting.text. It's a type, and this is a type of the variable t, and again then new com.acme.accounting.text. It's a long notation. Nobody wants to do that, so people are typically specifying import statement so the program knows where to find stuff. You can specify the name of the class that you are importing. If you are importing in several classes, then you can specify asterisk over there. But specifying explicit names that you are using in your program in these import statements is preferable way to do things. Why? Because it makes the program more readable. For example, if the package, again, I say package and you think directory. If the package accounting has 25 classes, and if you will put star over here instead of tax, then the programmer who will be reading your program will think, what this guy is importing from that package? There's 25 classes over there. It still will work, but it's preferable to specifically put a line for each class that you are importing. Again, the word import is kind of confusing. You're not importing, you're not sucking in the content of the class, you're just saying where to find it. That's the packages. And if you go back, do we have packages over here? Let me see. We don't have it over here. Do we have it over here? Yeah. See, for example, this is a lesson 6. Lesson 6 has something underneath, under SRC. See, I have a package com practical Java lesson 6. Let me see, test pay increase. Right, see, this is a testing program. It has import statement up on top. Import com practical Java lesson 6 asterisk. It means if you cannot find something, some class definition inside the program, go and check it out in the Com Practical Java Lesson 6 in here. Right now I am in the navigator view in Eclipse. If I'd be sitting in the package explorer, it would look a bit different. See, it looks like packages. It shows you like a Java view on things, because Java knows packages, and it shows you the name of the package in one line, right? But if you will open up navigator view, how to do this? Window, show view, navigator, if I wouldn't have it opened. If you open it as a navigator, then it'll show you a different view at the same thing, but it would show you from the file system perspective. You see that the package has corresponding directories and subdirectories. Okie dokie. As a matter of fact, if I will open any class over here, say constructor, right? Now check this out, up on top. You see that we are sitting in this workspace, Java Training Fab, and the directory is in lesson is SRC. Lesson 6 is a project, right? SRC com practical Java lesson 6, and the file is there. You can also see the exact location within the project up on top. Okay, and the next topic is data access levels. We are done with packages. Of course, I give you a brief overview, but I don't want to give you a content of a fat book on Java. You got an idea, do your homework. A lot of self-studying. Let's see. Now we will learn new keywords for you. Maybe you've seen some of them already. At least public you've seen. These are so-called data access qualifiers. Keywords. Public, private, protected. These are the qualifiers. So what public means? Public means that anybody from outside of this class, or maybe whatever it is, interface, or a variable, whatever, if you have an application with a bunch of different classes, and if anybody wants to use this that is defined as public, go ahead and use it. The least restrictive access. If I use the keyword private in front of something, I could use it in front of a variable. I can use it in front of a method as well. As a matter of fact, I can use it even, in front of a method, right? So when I said private double gross income, it means that the variable gross income will not be visible from outside of this class tags. Remember, like in my example, it was, we just saw it a minute ago. We had this T dot gross income is equal something, like this. If I would have specified gross income as private inside the class tags, I'd have an error over here. It wouldn't let me do this. Let's try. Tags. See, let me do this. I will specify this as a private variable. Save. Test tags. See, it's red. The field text gross income is not visible. I don't see it. Why? Because I made it private. It's not visible from outside, right? Private access. If you will specify something as protected, it means that this, in my example, it's a variable state, will be available and visible from anything from within this class text, of course, plus from any descendant, from any subclass of this class. So this is what protected means. Protected is less restrictive as private. To be honest with you, I don't like protected. I've been blogging about it many years ago. I think it's useless. It just makes the life of programmers more difficult. And I am happy to report that the new programming language from Google, which I like, it is called Dart. This language does not even include such qualifier as protected. I'm very happy. But if you're going to be going through a technical interview, looking for a job, please do not start this conversation, because most of the people believe that protected does your body good. And one more thing, if you will not put any of these qualifiers, such as private, protected, or public, then default access is so-called package access level. Again, there is no keyword package for this for data access in Java. But the meaning of it is simple. If you did not specify the access level, then it'll have package access level, which means that every other class that is sitting in the same package, again, think directory, will have access to these variables, or maybe methods that do not have explicit access level there. It's called package access level. Next subject of our lesson, next bit or next piece, the keyword final. We already had a chance to see at least once final when we spoke about final variables, but the keyword final can be used in different situations, and its meaning or it will result in different effect. Let's see. If you use the keyword final in the method signature, like I did over here, it's a method convert to Celsius. The Fahrenheit degree is converting to Celsius. Then this method cannot be overridden. Remember method overriding? Superclass, subclass, methods have the same signature. If in the superclass I specify this method as final, convert to Celsius. You cannot specify, you cannot override it. You cannot change the formula to convert degrees from Fahrenheit to Celsius, right? So if you will try to put the method with exactly the same signature in the subclass, you're going to get an error. Why? Because the superclass was final. You're not allowed to override it. Next, if you put the keyword final in front of the class definition, it means that you cannot even extend this class. You cannot subclass it. See a different effect. If you put it in front of a variable name, you make the variable final. We already went through this last time in Unit 2, and which means that you can assign only the value to these variables once and never change it later on. Final variables usually are named with capital letters, with underscore if you have multiple words in the variable name. And one more thing, starting from Java 7, you can specify the keyword final inside the catch statement in the exceptions. We didn't talk about exceptions yet. Exceptions is a way of Java handling errors. We'll have a special unit for that, but for now just know that there is a special construct try and catch. You put the code that might potentially give you an error inside the try block. If the code fails, it'll jump into the catch section over here, and it'll forward you the error message, what happened actually. So at some point they decided that you can put final in there, but meaning that you cannot change the variable which holds the error, the exception. But eventually they said that errors are implicitly final, so you don't even need to specify it over here. But if somebody wants to give you a test what is final and how it works, there are these cases where you can apply the keyword final. So basically we are about to be done with the lesson. I covered all the subjects I was planning to. I just want to tell you, for those people who subscribed, who registered for the consultation, for the extra session, so I am checking the homeworks of those people. From now on, I'm not going to be taking your homeworks as attached zip files to the email. I want you to do it professionally. I want you to create establish your presence online. And there is a public version control, public repository for all the open sources. It's not the only one, but one of the popular one is called GitHub. Over here, I put it GitHub. And the GitHub is a place where you can upload your open source projects. Not necessarily open source, but if you want to do it for free, then the code should be available for everybody in the world. So I recorded a video in here, actually, there is a link to the older video. You can watch that, or you can watch the video in my YouTube channel, or in YouTube channel of Farata Systems, and watch that and learn how to work with a Git, which is a version control system. And GitHub is a repository, is a hosting place for your source code. Many people around the world use it. In some cases, when you look for a job, they ask you to specify, to say in there, what's the URL of your GitHub repository? Do you have anything in there, maybe? So anyway, so watch the video, and from now on, if you are sending me your homeworks, do not send me the code, send me the URL to your GitHub project where you uploaded your homeworks or homework. Over here I mentioned that beside GitHub there is a nice place called Bitbucket. It also can host Git repositories, and it even allows you to create private repositories over there, which are free if you don't have more than 5 users. On GitHub, repositories are free if you open source your code. That's the difference. Anyway, watch the video and you will see it better. Now the homework. Study lessons 5 and 6 from the textbook. Do the assignments. Do your little research and find the difference between ++i and i++. Prefix and postfix increment. Read about what is immutable in case of strings in Java. Now compare these two different if statement. This if girlfriend is equal Masha, if you assign it as a literal, or compare these two variables, gfriend1 and gfriend2. What's the difference? Why it's not the same? Think about it, do your research, enter this, create a little program in Eclipse and run it and learn and study. Read about the loops and create a hello world program, or maybe use your text program and try to pass the values through the command line arguments. All right. Actually, you know what? Lesson 6. I don't think you need lesson 6, to be honest with you. I don't remember. I have the book with me, but if it's about 6, if lesson 6 is about casting and interfaces, that part you don't need to do this. Lesson 5 definitely. And I give you a whole bunch of articles to read, the additional materials, articles that I read and I like them and I think they are useful for you. That's about it. Thank you very much. It was lesson number 3, unit 3, from my training, Introduction to Java. For more trainings, you can visit faratasystems.com, and we have our training channel. Besides this training, you can find other presentation over there as well. Thank you very much. It was Yakov Fein.